Hi, Mr. Neely here, showing you how to make a dot plot. Now, a dot plot is a great way to organize data. Another great thing about this is you really don't have to put these numbers in order from the least to greatest to do this. However, you do want to make a number line that includes all the numbers and make sure you have enough space on top to put your dots. The smallest number I can see on here is 0. The largest number appears to be 11. So when I make a number line, I'm going to go down a few lines right there. And I start right underneath all that data. Give yourself some space. If not, you're going to have to go down below, and that's a little weird. All right, whenever I put my hashes down, I'm going to put down 0, 1, 2, 3. There's not as much data here, so I don't have to count by tens or 20s or by hundreds. But if you do have larger amounts of data, you might want to count it in a different way. Now, another great thing about dot plots is every number that you have up here, you can tell what it is down here. You don't have to sit there and go, well, you know, like a histogram, you have like you don't know if the numbers are 7, 8, or 9 or whatever. You can clearly tell when we're done. All right, so what I do is I just go from left to right, marking them off as I go. So the first number I come into contact with is, ironically, 1. I put a dot right there. You can also use X's. Those are called line plots. They're the same thing as dot plots. They just have a different name and a different presentation, I guess you can say. So you can hear the birds outside. It's a beautiful day out here today. Now, if I mess up and I have to go back down, you know, you could look ahead and see if you have a lot of ones. I may need to actually double up on these. So we'll see how that goes. And then we got 7. At least for the beginning, I definitely want to spread out a little bit. We have 2. We put a dot here. And then we put a dot at 0. And then over at 11, we put a dot above it. And another dot on top of 2. And another one. I might run out of room on number 2. I hope not. Let's see. All right, so we got 3. We got a 1. Got another 3. Got a 4. Oh, we might run out of room on the 2s. Okay, so here we go. I'm going to squeeze it in a little bit here. Yeah, you should try to play ahead a little bit, but sometimes it's just impossible. 2. I see another 2 right there. But I'm pretty sure I've seen, there's a lot of 2s. It's my mode. It's definitely my mode. So I recommend you try to move down a little bit more, but with the screen I have here, I wasn't sure if I had enough room. All right, so I got these 2s with those 2 right there, and then this one, I went ahead and kind of went ahead on that one. We got a 4 right here, a 5, and last but not least, a 6. All right, now, let's talk about this dot plot, other than the fact that these are not perfect up here. Forgive me. We can identify certain things like this is a cluster. Okay, so there's a cluster or a clump of information between 1 and 4. We also have a gap right here between 7 and 11, not the gas station. And 11, since it's far away from the rest of the data, we call it an outlier. Also, we can look at certain things like the mode. The mode is easy to see. It's clearly 2. However, in 6th grade, we more talk about the median and the mean, which you can easily see. If I don't have this original data, I can always go back and go, I have 0, 1, 1, 1, 2, 2. I can, list the data like 2, 2, 2, 2, 2, 2, 3, 3, 3, 4, 4, 5, 5, 6, 7, and 11. Those are my numbers, and I can just list them out, or I can put them in my calculator. What I normally do in my calculator to find the mean, I'll do like 0. I don't even put 0 in the calculator, to be honest with you. Sometimes I do stuff in my head, like I'll put 1 times 3 in my head, and I'll go, hey, that's a 3. But if you're not sure, you can always do 1 times 3, 2 times 1, 2, 3, 4, 5, 6. Ooh, there's 6 2. So you could put 2 times 6, 3 times 3, and then 2 times 4, and 5, 6, 7, and add those up, and then divide by the number of dots. So if this was the number of kids who got, I don't know, this many pencils in their book bag, you're going to say, well, what's the normal amount of kids that have pencils in their book bag? Well, the most common number of pencils in a book bag are 2. Kids carry around 2 pencils in their book bag. Oh, look at that naughty student. He only has 1. He has no pencils at all. He ain't prepared. All right, so this person over here, they're a Beaver. They have 11 pencils. Probably they're selling them on the side. You know how those kids are. All right, so we can also look at some of the data and go, okay, what's the mean amount? Well, again, you have to add them up. That's not as easy to see on this. The mode's the easiest thing to see on these. The median is not hard to find. You just have to go from side to side. Like here's this one, this one, this two. You know, you got to pair them up as you go. These two, all right? These two, these two, these two. It's kind of hard when you get toward the middle. At least one of my fingers there in the way. So I know my median is 2. So in the middle of the numbers, if I put them in order from least to greatest and went back and forth and hacked off left, right, left, right, left, right, 2 would be in the middle, which isn't hard to believe. There's a lot of 2s. So you can find the mean, you can find the median, and you can find the mode. And you can also easily find the range. Now 11 is the last number on my number line. Let me make sure I fix that, so that you won't assume that you take the last number you see and subtract the first number you see. That's not how it works. The range is with the last number with a dot above it, subtracting the smallest number with a dot above it. So the 11, there's a 12 there, but there's no real 12. There's no dot above the 12. 11 minus 0 is 11, so my range is 11. This is a great way to organize data and also display it, and you can see things like, oh, we talked about a few weeks ago with histograms, if it's skewed right or skewed left, or if it's symmetrical, or what we call a bell curve. I think you can look at this one and tell, if I didn't have all this, that'd be a pretty good little bell curve right there. But with that information, it's not a bell curve. It's much more of a skew to the right. Remember, when you say skewed right, it means you're like, almost like you're going up a hill and you're skiing down the other side, because that's the safe side. I wouldn't want to ski down this side. No, I'm not crazy. I go like that, like a sliding board. So this one is definitely skewed right. I hope this answers some of your questions. If you have any more, please bring them to our Zoom meetings. I will see you then.